Hi guys, today we are starting chapter 12 on surface area and volume of three-dimensional figures. So today we're kind of going to look at a lot of the vocabulary and just kind of some of the basic concepts dealing with three-dimensional figures. Now I will tell you that this is a this has a lot of vocabulary in this unit, so I want you guys to be prepared for a kind of longer vocabulary quiz. Okay, so let's go over some of the main vocabulary words here. First off, a polyhedron is a solid bound by polygons or faces. Okay, so it can't be like a sphere because that's not bound by polygons or faces. It would have to be flat sides, flat faces. So like an example of a polyhedra would be a prism of any sort, or a pyramid. Cylinders, cones, and spheres would be examples of non-polyhedra. All right, so a face, we should all know what that is by now. It's a flat side of a three-dimensional figure. An edge is where two faces meet. So an edge is usually going to be a line, and it's going to be where two faces of a three-dimensional figure meet. The vertex is going to be the point formed when three faces meet. All right, so looking at this pyramid that I drew, this is considered a polyhedron because it is bound by polygons. It's all the sides of it are polygons. So an example of a face would be this bottom part, right? So this would be considered a face. This also has four other faces that are the triangles on each side. An example of an edge, so we said where two faces meet. So if we look at this right here, this would be an example of an edge, right? This would be an example of a vertex. All right, so let's continue. Cross-section is an intersection of a plane and a solid. Here are some examples of different cross-sections of a cube. So if I was to get a two-dimensional figure, or a plane rather, and I was to cut it through the cube the first way, so at kind of an angle, then that cross-section creates a triangle, as you can see right here. Over here, if I was to have that cross section at a kind of more angled way, it can actually create a trapezoid with that angle. And over here, if it touches all of the all of the edges, then it can create a hexagon. So it just kind of depends on how you're angling the plane. It can create different types of cross sections with different types of figures. All right, so a solid of revolution is a three-dimensional figure formed by rotating a two-dimensional shape on an axis. All right, so for example, in this figure, you can see that it starts off as a rectangle, right? So this rectangle is going to rotate about the axis of revolution. Now, this right here, this right here is the axis in which it's rotating about. That is called the axis of revolution. Now, when you rotate that figure all the way around, as it's kind of showing, then it's actually going to create a cylinder. All right, so now we've already talked about the difference between polyhedra and non-polyhedra. We said that in order for something to be a polyhedron, it has to be bound by planes, basically, by flat surfaces. So here are some examples of polyhedra, and here are some examples of non-polyhedra. We said prisms, pyramids are polyhedra, cylinders, cones, and spheres are non-polyhedra because they are round. So let's look at some examples. So in the extra practice for the first one and the second one, it says to determine whether or not the solid is a polyhedron. If it is, name the polyhedron. So for the first one, I would say that yes, it is considered a polyhedron because it is bound by flat surfaces. And the type of polyhedron this is a convex octohedron. So octo because it has 8 sides, so it is a convex octohedron. For this, the second one, this is not considered a polyhedron because it is not bound by flat surfaces. It is completely round. So no, this is not a polyhedron. And guys, on the test, you won't have to worry about actually naming the different polyhedrons. You just kind of have to know whether or not something is a polyhedron or not. Now, continuing on, we're now looking at cross sections. So it's asking us to describe the intersection formed by the plane and the solid. So for this first one, we can see that we've got a plane that's intersecting a pyramid. Now, if we look at the shape that this creates, because it is parallel to the base, it's going to have the same shape as the base, which in this case is a square. Assuming that this is a square pyramid. Okay, for this fourth one, we can see that it is a vertical plane. So what it's going to create here, if you can see it, that is actually a triangle right there. It's kind of hard to see, but it is. This is a triangle. Okay, over here we have, it's kind of at more of an angle. No, sorry, it's actually quite straight. So when we look at that, that actually creates a, that is a trapezoid. For this next one, we can see that it is parallel to the base. So we can see that that has 7 sides. That is a heptagon. Or septagon, depending on what you prefer. All right, for questions 7 and 8, it asks us to sketch the solid produced by rotating the figure around the given axis. Then identify and describe the solid. All right, so for this first one, if I was to rotate that figure about the axis, we'll end up with kind of a cone that looks like this. All right, so it's kind of the bottom section of a cone. That's how I would describe it anyways. And if we look at the dimensions, this 4 is only half of it, right? But if we were to rotate it all the way around, this would actually become 8 centimeters. Now, over here, the width doesn't actually change. That's still going to remain 8 centimeters. Whereas the other side of the cone, because we are rotating it, it does actually double. So this becomes 4 centimeters. All right, so this section here becomes 4 centimeters. For question 8, if I was to rotate it, now we can see that the axis of revolution is actually vertical. So I'm going to be then rotating this section horizontally. When I do that, I end up with a figure that looks kind of something like this. So if I look at this, you can see that this is a cone superimposed on a cylinder. Okay, so if we look at this, now because it is rotating horizontally on a vertical axis, then I know that the base is actually going to double in size. So the base, instead of it being 8, it's actually going to be 16 centimeters. And then my height remains the same. So that's both for the height of the cylinder and the height of both of them together. So we know that the base of the, so the cylinder portion rather, is going to stay 2 centimeters. And then the entire thing is going to remain 4 centimeters.